Good morning, everyone. Today we are going to actually learn about two simple concepts, which are basically the very first one, algorithms and flowcharts. These are related with your chapter 7 of Byte 2. We all face actually problems in our daily life. When we face a situation for the first time, we may not know what steps to take. We also face problems when we have to make a choice. We should try to solve problems in an organized way. Before learning programming, you should know the basics of algorithms and flowcharts. As you know, programming is about in a computer. A computer can process information, but it cannot solve problems on its own. As you all know, computers cannot solve their problems by themselves. It needs clear instructions. A program is a set of instructions that tells the computer how to perform a specific task. Whenever someone writes a program, it gives instructions to the computer to perform any kind of task. Programs are written by people and they are called programmers. Programs are stored in the memory of the computer. The computer follows these programs to process information. How programs are created? A computer processes information in binary language. Programmers can write programs in binary language, but they would be too difficult for ordinary people to understand. Programmers write programs in a language that ordinary people can also understand. These languages are called user-friendly languages. So, user-friendly languages use words from common English, which are very familiar to us. To create programs easily, programmers follow some simple steps. There are two images in front of you. First one is binary language, as the computer interprets the program into its memory, and you can see a user-friendly language in which a program is written. And you are very much familiar with these words: sum, print, and so this is a user-friendly language. If we talk about the algorithm, step-by-step instructions are easy to understand. They are very easy for us to understand. They prevent confusion. So programmers need to write each instruction carefully to create accurate programs. An algorithm is a sequence of instructions that can be followed easily. It can be written in various ways. How to create an algorithm? We can create algorithms by breaking down each activity into simple steps. First of all, before learning about programming, you should know how we can write the algorithm first. So it's very easy, and we can create algorithms by breaking down each activity into simple steps. We then write a clear instruction for each step. When someone follows the algorithm to perform a task, he should obtain the desired results. Let's discuss some algorithms. The problem one, as given in your books, it's about simple addition of two numbers. The first one is 13 and the second number is 7. When you are writing the algorithm of adding two numbers, you will have to write first on a piece of paper, write down 13. Write 7 under 3 in the ones column, add 3 and 7, carry 1 to the tens column, write 0 in the ones column in the answer row, add 1 and 1, and write 2 in the tens column in the answer row. This is simple methodology of adding two numbers as we simply do in mathematics. So these are the just problems, and whenever someone asks you to write an algorithm, you can just write it down as such. Next thing is flowchart. It is easier to use pictures than words to share ideas. After a programmer has written an algorithm, what does he do? He prepares a diagram based on the algorithm. The diagram helps him see how the instructions would be followed by the computer. This makes it easier to detect errors. Flowchart actually is a pictorial representation of an algorithm. previously. First of all, you are going to write an algorithm, step-by-step instructions, and then you need to draw the flow chart, which is a pictorial representation of that algorithm which you have written, which we have discussed right now, adding two numbers. So before that, you should know flow charts help programmers plan and write programs. A flow chart uses boxes of different shapes to denote different types of instructions. The instructions are written inside these boxes in simple language. The boxes are connected by arrows to indicate the sequence of instructions. These boxes and arrows are called flowchart symbols. We'll be looking at different flowchart symbols one by one. The very first one is the start, and it's the ending as well. The start and symbol. The start and an end symbol is an oval shape. It represents the starting point of a flowchart. It also represents the end point of a flowchart. A flowchart begins with a start symbol with the word start written in the middle. It ends with an end symbol with the word end written in the middle. So first, whenever you are going to draw the flowchart, you need to first of all draw the starting and ending symbol, which is an oval shape, and just write start in between. Afterwards, it comes input and output symbols. Input output symbols are shaped like a parallelogram. It represents the stage where data and processing instructions are fed into the computer. It also represents the stage where the computer provides the results of processing the data. The shape you can see as well. The next shape is the process symbol. The process symbol is rectangular in shape. It represents the processing taking place inside the computer. It is placed between the input symbol and output symbol. Then the decision symbol, which is kind of diamond shaped. The stage where a computer has to make a decision is represented by the decision symbol. That is what is called decision symbol. It's deciding. So the decision symbol is diamond shaped. It contains a question with a yes or no answer. Arrows. Each symbol is in the flowchart must be arranged in sequence and connected with arrows. The arrows help the programmer move from one instruction to the next in the correct sequence. Flowchart symbols can be arranged in a sequence to create flowcharts for different algorithms. Let's see. Let's create them. If we talk about the same problem you have seen before, the algorithm is over here in front of you at addition of two numbers. You can see side by side the flowchart of this problem as well. The algorithm is there at the number 13 and 7. If someone gives you a problem like add the numbers, whatever the numbers are, and they ask you to write the algorithm, you will be just writing them as such. As you can see on a piece of paper, write down 13, you will be writing step 1, step 2, 3, 4, 5, 6, 7 as such. Just like you do in your maths, whenever you are adding two numbers, what you are doing, you're just writing 13 and then write 7 under 3 in the ones column. You will be adding 3 and 7 both and carry 1 to the tens column. Then write 0 in the ones column in the answer row and add 1 plus 1. You'll be getting your answer, and with ones column and tens column, just write 2 in the tens column in the answer row. The answer will be 20. You can just write it in a piece of on a piece of paper and you'll be getting answer 20. So over here you have just drawn a flow chart as well. Start and end symbol at first place, then input. There are two inputs. First input is 13, then input 7. Again there is output, which is input, which is 13 plus 7. The output is 13 plus 7. So you'll be just adding them as well. After input stage, the symbol which comes afterwards is add is processing symbol, which is in yellow color. And what does it do? It add ones columns. It's adding ones columns. The processing is going on. It's addition, so it's adding two numbers. And before addition of tens columns, it's initially adding ones column. So and it's checking in the decision box, which is the green one. It's checking which is the deciding stage. It's deciding that is the answer greater than 9. It's checking that if the answer is greater than 9, so you'll be looking at that 13 plus 7. Yes, the answer should be, the answer is actually above than 9. So what does it do? Yes. Yes means answer is greater than 9. So it's going on the yes track, and it's taking it again to the processing stage, which is carry digit to the tens column. Yes, if the answer is greater than 9, yes. So it will be going on the next track, which is carry digit to the tens column. If if the answer is no, means is answer greater than 9. If you are taking other numbers below, like you are taking 6 or plus 2, so answer will be 8. You don't need to go to the yes path. It will be just going to the no. Yes, is answer greater than 9, then in that case, if answer is not greater than 9, it will be going on no path. So it's the deciding place which is deciding between these two things. If the answer is greater than 9, it's going on yes. Carry digit to the tens column. Yes, of course, only then we are in need of carrying digit to the tens column. And again, it adds, then afterwards add tens column. Then it will be adding tens column, and output will be 13 plus 7, which is 20, and then end. Similarly, problem 2 is the subtraction of 13 from 22. 22 you will be writing at the top, and then you will be subtracting 13 from this 22. Notice that 2 is less than 3 in one's column, and whenever you are subtracting 3 from 2, what you need to do is you will be checking in the flowchart as well. The green box is 2 smaller than 3. Yes, 2 is smaller than 3. So what can we do? We need to take a borrow from the tens column. The answer is yes. We'll be going to the next part, which is borrow 1 from tens column, and then again subtract ones column. On the other hand, if you are having numbers which are lesser, as given over here, if the numbers are lesser, and then you can subtract easily. You just don't need to go to the yes side. You will be just simply going to the no path, and then subtract ones columns, subtract tens columns, and output will be 22 minus 13. Simply, you can just subtract these two numbers in such manner. So in this manner, you can just write any kind of algorithm of drawing flow charts side by side. Next thing which we need to discuss today is selection. Whenever you're selecting between two things, you should know there are many options for a simple thing. Throughout the day, we perform several activities such as going to school, doing homework, helping our parents, and so on. We can break down each of these activities into simple steps. For example, while doing homework, we first check our diary. Then we start with one subject. We attempt each question in turn. When we have attempted all the questions, we move on to the next subject. In each task, we need to make a selection. For example, after completing one task, we check if we have answered all the questions. If a question remains unanswered, we attempt to answer it. When we have attempted this question, we again check it. If we have answered all the questions, if a question remains, we attempted that too. Each time we check if we have answered all the questions, we are making a selection. We are selecting that we have we answered all questions or not. In the similar way, you are doing in your papers, exams. You're checking have you done all questions or not. If not, then you do them again. So we have to select from two options: pack up our books. If you have done your work, yes, definitely you'll be packing up your book. Otherwise, keep doing homework. If you have not answered the whole all questions, then definitely you need to continue with your homework. So what a condition. This was selection I have discussed with you. So I'll be going to condition. You should know what a condition is. We can select one of the two actions. Which action we select depends on whether all questions have been answered. This is called a condition. It is a necessary requirement for an action. We can write the condition in the form of a question. Have a questions been answered? Have all questions been answered actually? So this question can be answered yes or no. If the answer is yes, we pack up our books for the next day. If the answer is no, we continue with the homework. In programming terms, we can say that the condition might be true or not true. Checking whether a condition is true or not true is called testing the condition. There are two kinds of statements, conditional statements, which we are going to discuss today. The first one is if-then statement. In previous example, we have tested if a condition have all questions been answered was true. We then perform an action depending on the answer. Such a choice can be written in the form of if-then statement. If-then statement consists of two parts. It tells us what the condition is. It then tells us what to do if the condition is true. If the condition is not true, then we automatically continue doing what we were doing previously. Let's create an algorithm for completing our homework. So, check homework diary, start homework. Answer the first question. If all questions have been answered, then start packing up. If all the questions have not been answered, answer the next homework question. We can also draw a flowchart for the algorithm. Do you remember the flowchart symbols? We have discussed simple input-output symbols, process symbol, decision symbol, and arrows. If you follow the arrows of the flowchart with your finger, you will see that you can travel in two different directions from the decision box. The decision box contains the conditional statement. One of the arrows tells us which path to take if the condition is true. The other arrow tells us which path to take if the condition is not true. This was previously discussed if-then statement, now if-then-else statement. They both are same but a little bit different. If in the previous example we had two options, we could either do a different thing, back up, or continue doing what we were doing earlier. There can be times when we might select between doing two things together instead of either doing a different thing or continuing with the same one. Let's continue with our example. Suppose you have finished packing up after completing your homework. There is still some time before dinner. What are you doing? What are you going to do? There are several things you might to do. You might either ride your bicycle or tidy your room. Which one would you select? We can write such a selection in the form of if-then-else statement. An if-then-else statement consists of three parts. First, it tells us what the condition is. Then it tells us what to do if the condition is true. Finally, it also tells us what to do if the condition is not true. If then statement does not tell us what to do if the condition is not true. So it also over here it's providing you the answer for the condition if it's not true. You can have another option for that. Previously it was not there. This is why we move to the next step, excluding the ones linked to the condition. Let's see for the further understanding. Let's create an algorithm for selecting between two different activities. We'll be using if-then-else statement over here. Have a look outside. If there is still daylight, then ride a bicycle. Else tidy your room. Have a dinner then. Over here, start and end symbol. As you can see in flow chart, check homework, attempt questions. Have all questions been answered? Yes, back up. Otherwise, no, and going back. And if the null statement is deciding between two tasks, the first one was, is the still daylight? If yes, then ride a bicycle. If no, then have a dinner. Tidy up your room and then have a dinner. Tidy up your room is again an option over here. We can also draw a flowchart for this algorithm as you can see. And in this algorithm, look outside. Is there daylight still? Yes, ride a bicycle. Again, is there daylight still? No. Tidy up your room. And then have dinner in both cases and end. This is if then else statement flowchart. That's it, students. This is the bookwork as you can see in front of you. The answers of MCQs, there are just options given over here. Please be careful in doing your bookwork as well. And question answers. Exercise D. There are, I think, 7 question and answers altogether of this chapter. This is the last one. It's having algorithm and its flowchart over here, as you can see. So do it neatly in your notebooks. Thank you so much. Take care of yourselves. Have a nice day.